you had a look at this puzzle last time. And I wonder if Amy,
Yes.
this is a nice simple question to start off with. Can you remember what does this puzzle represent? What were we learning about when we saw this?
We're learning about bits and bytes.
Bits and bytes, good job. And when you've got bits and bytes, and you build them up, what do they create in ones and zeros?
They create kind numbers.
Numbers, yeah. Can you remember what that code is called?
Binary
Code, yeah.
codes.
Yeah. Binary code, that's cool. Thank you, Amy. So we had a look at binary code, which is made up of bits and bytes. Ling. Bits and bytes are both units of processing power. Okay. Can you remember which one is smaller, a bit or a byte?
Right.
A bit is smaller. If you think it's only a little bit, right? And there are 8 bits in a byte. So Ling, which one's smaller? A bit. Yeah, that's right. A bit is smaller than a byte. The same way that 10 millimeters make a centimeter, 8 bits make a byte. I want to show you. Can anybody remember, or can anybody tell me what number this represents in binary code? Now have a look at these underneath in the orange boxes.
22.
22, good job. How do you know?
Because it's of 1 of 16 and 1 of 14, we will do as 1 times 60 plus 1 times 4 plus 1 times 2 is equal 20.
22. Good math. That's right. Okay, thank you, Bill. So yes, this represents 22. Obviously, there are other ways of building binary code. So it represents letters and colors. That's when we get pixels. When we get like a pixelated image, it's all the blocks. So it knows what color to make the squares. I was wondering if anybody can tell me what's going to happen if my code is sent like this. What happens if I don't put anything in the bits? But if it can only send if it's got a full piece of binary code.
If we don't have a complete code, then we can't make the number.
Yeah, we can't make numbers because, yeah, exactly. So this is code interrupted. And we'll have a look at that in a few minutes. What happens? How does a computer process information? Now, I'm going to give you some prompts on the screen in green, and I want you to use them in a full sentence. For example, the first one is electrical signals. Now, can anybody tell me, what does electrical signals have to do with computer processing? Hey, Anna, can you remember, what do computers do with electrical signals? Do they block them, or do they send them, or do they use
Send.
Yeah, so they send electrical signals within itself so that it knows that when you press F, it needs to show an F on the screen. So that's one way. Good. And then the next bit I've got is the motherboard or the circuit. Why is that relevant? Zhang, what does a circuit have to do with a computer?
The circuits need to connect with the computer.
Yeah, so the circuit is what the computer is built up on. What do we send around the circuit?
Electrical signal.
Yeah, good job. So thank you, Zhang. So we send electrical signals around a circuit, or a very complex or complicated circuit called a motherboard. That's how it processes information. Bits, bytes, and binary code. What does that have to do with a computer? Rito?
Bits and bytes are...
They're the unit of computer processing. What do bits and bytes have to do with binary code? How are they connected? So to build binary code, what do we use? We use bits and bytes to build up binary code. Do you remember?
Yeah.
Yeah, cool. That's okay. And lastly, CPU versus the brain. Maybe Greg, can you tell us? Greg, how are a CPU and a brain similar?
They both process information.
Excellent. They both process information. And what do they both send?
Signals.
They both send signals. Good job. And can you remember which one's... Yeah. And can you remember which one's faster?
The CPU.
The CPU. Good job. Why do you think that is?
Because it's a machine and the brain is just a compact, piece of meat.
Yeah, good job. Which one do you think has got more electricity or more powerful electrical signals?
The CPU.
Yeah, the CPU. Good job. So that's
So it
why
can send electric. So it can send electric signals more
That's right.
fast.
Yeah, that's right. Good job. Thank you, Greg. Okay, so we've got a little bit of reading here, and we're going to read through this together, and I'm going to highlight a little bit. Okay, would everybody please turn their microphones on?
Streaming to RTPs from wireless internet modem or
to our devices. We can even listen to music and relay signals from satellites. All of these rely on electronic signals transferring of code from one place to another. However,
internet video that would not play have experienced
had a different thing called an internet video that have experienced interrupted
Digital code. Good job. Okay. Guys, what have I highlighted in yellow?
These things rely
Yeah, these things rely on electronic signals transferring bits of code from one place
to another.
Good job. But what can happen? What's in pink?
These signals can be interrupted.
Good. So, like when I was showing you the puzzle and I didn't fill in all of the bits with either a 1 or a 0, that's an example of interrupted code. It means it's not a complete code and it can't be sent properly. Have you guys ever experienced a buffering video or a website that crashed?
No.
No. Oh, you lucky things. Me, I have. If binary code won't transfer, the number of bits a device can move or process is a constraint. Can you remember what a constraint is?
It's like contrast.
Not quite. You're thinking of compare and contrast. A constraint is a limit. If a signal has too much information for the network to move, it slows down or stops. Now, think about when you've been trying to watch a YouTube video and it's not buffering properly. Has anyone ever had loads of tabs open at the top in your browser? Yeah, me too. What can you do with those tabs to make your video load? Sean, have you ever been trying to watch a YouTube video, but it won't load? And you've got lots of tabs open at the top of your browser?
No.
No? Okay, fine. I'll ask you the next question then. I have. If you close your tabs, then it means your computer isn't trying to send or receive as much code. Okay, and if you reduce the amount of code that it's trying to send, then it's able to buffer faster. You might have seen this screen before, or you might have seen this screen before.
No.
When it kicks you out of an online game, as okay, but that's what happens when the code won't transfer either fast enough or it's been interrupted. Now, error. Has anybody seen this screen before on their computers? Yes, no, maybe. Right, well, what's happening here? With your mics on? What is happening?
Error messages appear often on computers and tablets. It means there is a communication problem between parts of the system. Other times it means that the meaning of bits
Yeah, okay. So if you see the blue screen, that means that there's a problem within your computer. If you see the blue screen, it means that there's a problem with the information inside your computer. You might have asked it to do too many things. It might have crashed, like my laptop crashed because it got too hot. And so that meant it couldn't send all of the code over in time and it's crashed. So all of this It's all different ways. If you've got the blue screen, if you've got a buffering video, if you've got a website that crashed, it's all to do with code being interrupted. How is information transferred between computers? Now we're going to talk about the internet super simply. Computers communicate in code, binary code. We know this. We've established this already. They send electrical signals with this code to a modem. Okay, so we know electrical signals. You might have heard modem before. And what a modem does is it operates like a code breaker. Do you remember when we were doing Morse code and it was almost like a translation? It showed you what the alphabet was in Morse code, and you could use that to figure out each other's messages. Okay, that's a code breaker. The modem receives the code from one computer and translates it to a code that another computer can read. Ben, why would you maybe not want everybody to receive your computer information? Why do we need to send it through a modem? Why do we need to send our information through a modem, do you think, instead of just sending it to all the computers everywhere?
Because if we send it like that, even our private stuff will be sent to the other computers.
Exactly. Yeah. They'll know what you've been looking at. They'll know where your computer is. They'll know how often you've been using it, what time you've been using it. So we send it through a modem so that it concentrates it and just sends the signals to where you want it. Cool. But what about the internet? I think that's what it says. This is how the internet works in a very basic sense. Suppose you want to send an email. How does it work? The sending computer translates a message into codes that can be sent. So we can see Dear Grandma has been translated into binary code by the computer. The codes are first sent through your local area network or LAN, which is made up of modems in a virtual neighborhood. So it pings it around to different modems, which all translate the code. Codes can be sent in packets of data. These packets are then sent around the world via underground copper wires as electrical signals, or if you want to send it under the ocean, which I think is quite cool, fiber optic cables as light energy. Fiber optic cable looks a little bit like this. Leila, can you think of any code that we've looked at before that can be sent using light? What if I went flash, 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 flash? Do you remember Morse code?
Oh, yeah.
Yes.
The dots and dashes.
Yeah, exactly. The dots and dashes that can be sent. They can be sent either with sound waves, electrical signals, or with light. You could do that over distance. Okay, we've only got a couple of minutes left, so let's just get to this part here. Right, I'm going to turn your microphones on, and I've got 8 points. There's 4 on this page, there's 4 on the next page, and I'm going to tell you what you're doing next week. Everybody, can you please turn on your microphones and read this summary page for me? So, in summary. Computers.
Information enriched light and binary code. Send electrical signals if the code gets interrupted with the computer. It creates an error message. If the code gets interrupted online, it creates a buffering symbol or it crashes.
Good job. Jaime, what happens if the code gets interrupted within the computer?
An error message.
Good girl, yes. And Sean, how does a computer process information?
In bits, bytes, and binary code.
Lovely, thank you. What do computers send, transfer information? They send electrical signals. And cool, okay, everybody, mics back on, please. Last page. Right, I'd like you to read to transfer information. Ready?
To transfer information to another computer. The code can send in packets of information. These packets of information can be transferred by underground copper wires as electrical energy or
fiber optic cables as light energy.
Good job. Ling, can you tell me what kind of cable do we use if we want to send information as light energy?
optic cable.
Good job. Fiber optic cables. Greg, what kind of energy do we use to send computer information through copper wires?
Electrical energy.
Good job. Thank you very much. Okie dokie. So, guys, does that make sense so far? I've tried to make it as simple as possible. Does it make sense? I'm afraid we're still not done. We're still not quite done with this unit. So next week, we're going to have a look at radio waves, cell phones, and elephants.